it's how we identify elements, by their protons, not neutrons, not electrons. Can you find the number of neutrons from your periodic table? In this video, we're going to talk about what makes atoms of different elements unique. So, first of all, let's start off with a periodic table. I hope you have one handy. I mean, you need a copy handy all the time in chemistry. So, the periodic table contains all of the elements and they're arranged by atomic number. An atomic number is that big number that you see generally at the top of the box. So that is the atomic number, and that also tells you the number of protons. So if you see neon, you know that every neon atom has 10 protons. And if it's an atom, it's also going to have 10 electrons. So it is like, it's how we identify elements, by their protons, not neutrons, not electrons. So it's like a jersey number. Like say you're watching a football game and number 10 makes a great play and you say, well, who's number 10? Well, grab your roster and look up number 10. All right, so we've also got the symbol and the name of the element in the box. Now, the question is, what is this number down here? Don't use that quite yet. It's going to take me a little bit, but we'll get to that number. But for now, just hold off on that. The big number is the atomic number at the top, number of protons. Now, since atoms are electrically neutral, they have the same number of protons and electrons. So not only does atomic number tell us how many protons, it also tells us how many electrons. So if the charge of each proton is +1 and the charge of each electron is -1, this atom is electrically neutral. Because remember, neutrons have 0 charge, so they don't impact the charge at all. So here is a little model of the lithium atom. Now remember, it's not to scale. Those electrons should be really far away. But if you add up all the particles, the total charge is 0. Now, what about neutrons? Can you find the number of neutrons from your periodic table? And the answer is no. Okay, so you're thinking, well, what is that number? Could I get neutrons from there? Nope. Is neutrons 3? Not necessarily. So how do we find neutrons? There's something else we have to look at to determine the neutrons. So first of all, atoms of an element can have different number of neutrons. Some are heavier than others. And the atoms of the same element that have different number of neutrons we call isotopes. And there are different isotopes of each element that occur in nature. Why is it that way? I'm not really sure, but that's what we observe. So, for example, lithium, naturally we have 2 isotopes that occur. And you can see that the most common isotope of lithium is lithium-7. So let me show you what this little symbol means, and then I'm going to define something called mass number for you. First of all, what we know about lithium is atomic number, right? Every lithium atom is going to have 3 protons. So in the lower left-hand corner, we're going to put the atomic number. Okay, and that is the number of protons, right? We've got 3 protons. Now, what is this number on the top? The number on the top is what we call mass number. This is the number of protons plus the number of neutrons. So you notice that the total varies, right? One is 6 and one is 7. So that bottom lithium isotope has 1 extra neutron. So what do these both have in common? Protons, 3. Why 3? Because it's lithium, and lithium always has 3 protons. Now, what about neutrons? Well, the total number of particles is 6. So this is protons plus neutrons, and this number is protons. So how do we get number of neutrons? Well, just subtract away the number of protons. What do you get? I've got 3 neutrons here. 7 minus 3 is 4 neutrons here. Okay, so the only difference in these 2 isotopes of lithium is one has 1 more neutron than the other. So in order to determine the number of neutrons, what do you have to have? The mass number. Is that on the periodic table? It's not. Okay, Now, let's do a little practice here. Let's say I have an atom that has 19 protons, 19 electrons, and 20 neutrons. Can we write the atomic symbol? Well, first of all, we have to identify what is the element. We identify element by protons. So element number 19 is potassium, and the symbol is K. Now, that number of protons, the atomic number, goes on the bottom left. Okay, so we already know that. This thing is electrically neutral. I noticed that the protons and electrons are equal, so that's an atom. And then how do we get the top number, the mass number? Well, the mass number is equal to the protons plus the neutrons. So 19 plus 20 is 39. So this is element or isotope potassium 39. So the hyphen notation, we're just going to write the name potassium hyphen 39. Okay, and occasionally you'll see that K hyphen 39, but that's generally the way you write hyphen notation. Now, one more. Let's do a little quiz here. I'm going to give you an isotope. This is chlorine 37. And I've already given you the little box for the periodic table. So let's see if we can break this down and determine all of the particles of this isotope. I want to drop down and do the atomic symbol first. I think this would be a little easier. So atomic symbol, I'm going to use the symbol for chlorine, Cl. Hey, just while I'm thinking about it, always use a capital first letter. Don't go lowercase. Then we're going to put the atomic number here, right? The atomic number is the number of protons, okay? And that is, for chlorine, that is 17. And then what goes on the top left? That is the mass number. That's the protons and neutrons combined. Well, we got the mass number right here. That is 37. Okay, so the protons and neutrons is 37. All right, now let's go do the particles. Protons, easy. Atomic number, 17. This is an atom. It's electrically neutral, so electrons will be the same as protons. And then how do we get neutrons? Well, we've got the mass number, which is the total, and we're going to subtract away the number of protons. Remember, 37 minus 17 gives me 20. So the mass number tells you the total number of particles in the nucleus, right? I've got 17 protons and 20 neutrons. Those are all the massive particles. So that's what the mass number is. And then the electrons, do they add to the mass? Not so much. So I hope this helps you get a feel for how to determine the number of protons, neutrons, and electrons for any isotope.